Uh, Good morning, class. We are looking at college algebra practice test, which is part of the final exam. For this case, we are looking at module 5, covering chapter 9, sequences and series. And I'd like to start reminding everyone when we take the exam, we can't receive any help from any source. We are taking the exam on our own. That's why we have this pledge. I can't emphasize this. All right, we want to find the finite sum if it exists for the geometric series. When it mentions a geometric series, of course, you really have to look at two things. What is the first term? What is the ratio? So in essence, you have to make sure it is. So it says -2 plus 0.5 plus -0.125. And it continues indefinitely. And here's a geometric sequence. Remember, the recursive format a sub n plus 1 is r times a sub n. That means a sub the previous one times some constant, in this case r. Explicitly, a sub n is a sub 1 r to the power of n minus 1, and mostly we are interested in that. And to do so, we have to look at a couple of things. First and foremost, what is a sub 1? Obviously, is -2. And then we need to find r. To find r, all you have to do divide 0.5 by -2 and double check by dividing -0.125 by 0.5 to make sure it's the same thing. So when we do the division, it becomes -1/4. And you can try it with these two. -0.125, let me write that. If you do these two, -0.125 times +0.5, also we get to the same answer. And now we notice that r is between -1 and 1. Therefore, the infinite sum has the easy formula a sub 1 over 1 minus r. So what is a sub 1? -2. 1 minus, what is r? -1/4. And of course, this is plus or 5/4. And -2 divided by 5/4. That means, let me write it here, -2 over 1, 5 over 4. You're dealing with the complex fraction, the product of these two over the product of these two, which is -8 over 5, which is an exact answer. So very straightforward. Find the infinite sum if it exists for this summation of 1 to infinity 9 times 1/4 to the power of k minus 1, and you recognize this as a geometric series because you're adding up. Geometric sequence, when you write one by one, it becomes a series when you add them up, and summation means adding up. So you look at this one. In fact, if you look at this one and just compare it with this one, you can see that a sub 1 is 9 and r is 1/4. But let's write it. If I put k equals 1, 1 minus 1 is 0, 1/4 to the power of 0 is 1, so we get 9. If I put 1, I get 9. If I put 2, 2 minus 1, I get 1. 1/4 times 9, which is 9/4. And the next one is 9 over 16. Again, either just write out, it's really a good practice to write out a few, or just if you compare these two, you can see that a sub 1 is 9 and r is 1/4, or divide this one by this. And that's what we need. Because r is 1/4 between -1 and 1, we can find the infinite sum, the sum as n goes to infinity. That's the meaning of it. Is a sub 1 over 1 minus 1. You're going to use that formula, everybody. Plug in. So a sub 1 is replaced by 9, 1 minus, or is replaced by 1/4. And of course, this is 3/4. 1 minus 1/4 is 3/4. And the reason this is 12 is very simple. This is 9 over 1. Okay. So let's write it in this one. 9 over 1, 3 over 4. The product of these two, 36, divided by 3. So the answer is 12. It's a simple case of a complex number, complex fraction. Application problem. On each swing, left to right or right to left, a pendulum travels 90% as far as on its previous swing. The reason is because of the gravity. If the first swing is 10 feet, determine the total distance traveled by the pendulum before coming to a complete stop. As far as the pendulum is concerned, class, if there is no gravity, this continues indefinitely. And so of course, sometimes they have a battery, that's why it does. Because of the gravity, whatever it covers, it becomes smaller by a tad, and eventually it stops. That's the idea. So I hope you recognize this as a geometric sequence. Why is that? Two things. This says on each swing, a pendulum travels 90% as far as on its previous one. So this is R, and the first one is 10. So R is 0.9 or 90%. A sub 1 is 10 feet. So just for the sake of argument, it means we are looking at 10 and then 0.9 times that, 9, and then 0.9 times that, that means 8.1, and it continues. So that is the geometric sequence we are looking at. And now we want the geometric sum. We want to add them up. And to add them up, we notice that R is between -1 and 1. Therefore, we can use a sub 1 over 1 minus 1, which is 10 over 1 minus 0.9. 1 minus 0.9 is 0.1. 10 divided by 0.1, that means 10 times that. It's 100 feet. So this will cover 100 feet total before it comes to an end. This is a complete revolution, if you pendulum, going from point A to point B and coming back. And this distance, the first one going and coming back is 10 feet. The second one is a tad less, and so on. A ladder consists of 31 rungs. If the rungs taper uniformly, we're going to pay attention to this in a moment and what it means, from 18 inches to 28 inches, how much material would be needed for the 20th rung? So we are looking at a ladder, and the fact that it tapers uniformly and it starts from 18 and goes to 28, that means you start with 18, you add something. Taper uniformly means you add some constant until you go from the very first one, 18, to the very last one, 28. So you add the same amount, and that shows you're dealing with an arithmetic sequence because you're adding uniformly, you're adding a constant. Taper uniformly, you're adding a constant d. That's the idea. So let's go back to the first number. How many n is 31 wrongs. The first one, a sub 1, is 18 inches. The last one, because there are 31, the last one must be a sub 31, and it must be 28 inches. So that is important to understand. So the very first thing is to understand what we are dealing with here. So one more time, just to make sure we understand. If the wrongs taper uniformly, that means we add the same amount or we subtract the same amount. Okay, we don't know which one, but because it goes from some number to a larger number, that means we are adding. Okay, but taper uniformly can be either way. So that means an arithmetic sequence. The first one, a sub 1, is 18. The last one is 28. Now there are 31 wrongs. The last one makes it a sub 31 because n is 30. And so with that being the case, we want to know how much for the 20th, which means we need to find the d. We have a sub 31, we have a sub 1. We can use the fact that a sub n equals a sub 1 plus n minus 1 times d to find the d. So we're going to use this formula, and we're going to use the fact that these two are given. So a sub n is a sub 1 plus n minus 1 times d. So a sub 31 is a sub 1 plus n minus 1, 31 minus 1 times d. A sub 31 is 28. A sub 1 is 18. 31 minus 1 is 30. So this is 28. This is 18. 31 minus 1 is 30. We are subtracting 18 from both sides. We get 10 equals 30. D divide by 30, and D becomes 1/3. And now A sub 20, using the same formula, A sub 20 is A sub 1 plus N 20 minus 1 times D. So A sub 20, we don't have it. A sub 1, we have it as 18. 20 minus 1 is 19, and we have the D as 1/3. So this is 19/3. I hope you realize 18 divided by 3 is 6, and 18 is 24, and 1/3. I hope you can see it's easy. So if it were 18, we would get 6. Since it's 19, 6 and 18, 24 and 1/3. So that's an easy summation. I hope nobody has any problem. How much material would be needed for all of these 31 wrongs? So how much do we need? S sub n. And we have two formulas. However, since we have A1 and A sub n, it's easier to use this one. This one class, if we have only A sub 1 and not A sub n over 2, brackets 2 A sub 1 plus n minus 1 times d, And this one is easier if we happen to have both of them, the first one and the last one. Well, replace the n with 31. See, that's why we write the given here. N with 31, a sub 1 with 18, a sub n with 28. 18 and 28, 46. 46. And to cancel each other, 23 times 31. Total of 713 units. Inches, okay? Inches. It's important to use the proper units, everybody. All right. So again, pretty straightforward. Now, let's remind everybody of a couple of things. The factorial symbol and binomial theorem. If n larger than or equal than 0 is an integer, the factorial symbol, n factorial, is defined as follows. 0 factorial is 1, 1 factorial is 1, and n factorial means n times n minus 1 times n minus 2, all the way times 3, 2, 1, when n is larger than or equal to 2. That's the definition of a factor. Let's add a couple more things. So n factorial is n, and if you want to stop times n minus 1 factor, anytime you stop, you have to put a factor, unless you go all the way to 1. So for example, I can say 10 factorial is 10 times 9 factorial. Let me just write that as an example. That's the meaning of it. 10 factorial is 10 times 9 factorial, just as an example. All right. Now, combination. There are three ways of writing combination class. NR, CNR, or parentheses NR, N factorial over R factorial, parentheses N minus R factorial. This is called a combination. Okay. If we want to simplify this as an example, what do we do? Well, since the bottom is smaller than the top, we're not going to touch that. This one, we use the fact it's equal to that. So we're going to write 12, 11. We go all the way till we hit this number, and then we don't continue. We make it into a factorial. These two cancel each other, therefore. So it's 12 times 11, 132. That's how we did it. Of course, when it gets involved, you can use a calculator class, and that's fine. But it's important to know how to do it by hand if need be. Now we have a binomial theorem. X plus a to the power of n is n choose 0. It's a combination of n choose 0. X to the power of n choose 1, combination of n choose 1. A, x to the power of n minus 1. In other words, x to the power of n minus 1, a to the power of 1. And we continue all the way to the n, a to the power of n, and somewhere in the middle, nj would be a to the power of j, x to the power of n minus, in any. Just to remind you of a couple of things we have done before. Everybody remembers a plus b squared is a squared plus 2ab plus b squared. That is a binomial theorem just for n being 2. What happens when n is 3? A plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. This is the same binomial, but in the case of n being 3, everybody. So how would we write this in this notation with this summation? X plus a to the power of n, summation r going from 0 to n factorial over r factorial, n minus r factorial, this combination thing. X, the first one, to the power of n minus r times a to the power of r, and r starts with 0. So if you replace it with 0, everybody, this becomes x to the power of n. This becomes actually 1, and this becomes 1. It basically becomes x to the power of n. So it becomes a squared here, a cubed here, and so forth. And I'm going to leave it for you that you try the following. Show n choose 0 and n choose n are 1. N choose 1 is n choose r is n, choose n minus r. In other words, if these two numbers, look at the bottom numbers, if they add up to n, these two are identical. Just to make up some example for this one. What this means, if this is 12 and this is 12, if I not have a number smaller than 12, for example, 4 here. Now, 4 added to what number is 12? 8. These two must have the same answer. And this is the last one, actually. This is very straightforward, everyone. Just n0. So just follow that. You put what? N factorial over 0 factorial, n minus 0 factorial, which is n factorial, or n factorial, which is 1. This works the same way, and you can do the rest of it. We really should practice this to make sure you have no problem evaluating it. Use the binomial theorem to expand 3y plus 2 to the power of 4, and reminding everybody. For non-negative integers n and r with r less than n, x plus y to the power of n is what I mentioned there, which is there are two ways to write them. Summation r going from 0 to n of n choose r. N choose r is this. And these two are the same. X to the power of n minus r, y to the power of r. So again, this part, everybody, is the same as this part. That's what we're doing in any. And then the expansion and so forth. And these are the stuff that has been mentioned. All right. So following that, we are going to start with this. Okay, so let's go with this one rather than this one. So 4, so n is 4, everyone. N is 4. So 4, 0, 3y to the power of 4. Then 4, 1, 3y to the power of 2 to the power of 1, and so on. So I hope you can see that. So one more time. N is 4. So all of them have 4 here. We start with 0. Okay, we start with 0. This one to the power of 4. Then this one to the power of 3 to the power of 1. Notice. Then this one to the power of 2. This one. The exponents must add up to 4. The exponent here is 1. Okay. 3y to the power of 1, 2 cubed. And 3y to the power of 0 becomes 1. That's why we don't write it. Okay. And it's important to remember this one obviously is 1. So is this one. Remember that. Cnn and Cn0 is 1. And C41, this one, Cn1 is n. You can show that. And by the way, these two are the same, because remember what I told you? As long as these two numbers add up to the top, they are the same. So you really don't have to worry about this one is 1, this one is 4, this one is 1, so is this one 4. You have to evaluate this one. So 4, 1, and 4, 3 are the same. So let's evaluate 4, 2, which is 4 factorial over 2 factorial, 4 minus 2 factorial. So this is 2 factorial, this is 2 factorial, which makes it 4. And this is 4 times 3 times 2 times 1. And it simplifies to that. If you want, you can do it this way, everybody. What color do I want to use? Okay. So the top is 4, 3, 2, 1. 2 factorial is the same as 2. So the answer is 6. So in other words, we have this one as 1, we have this one as 4, and this one was the only one we needed to calculate as 6. This one, again, by theorem, is the same as this one. I don't have to calculate it. It's 4. You can try it, by the way, and this is 1. And we're going to simplify. So 3y plus 2 to the power of 4 is this, 81, y to the power of 4, this, 4 times 2, 8 times 27, 216y cubed, plus 6 times 4, 24 times 9, again 216, and 4 times 8 times y squared, 4 times 8, 30, 2 times 3, 96, y, and this is 16, and that's your final answer. So I don't think it's going to be difficult to expand. I hope it's not. That's binomial theorem. They may be interested in a specific term. Find the 7th term in this expansion, y plus 3 to the power of it. You have two choices. One is just expand it and start counting the first one, the second one, and get the 7th. That can be done. And it's really not that big of. Is there a faster way? And that's what we want to discuss. If you look at this one, the rth term of a binomial expansion, we said x plus y to the power of n has this formula. Or when you expand the n or the combination, you get n factorial over r factorial n minus r to the power of r factorial times n minus r factorial. So the rth term of the binomial expansion of x plus y to the power of n, where n is larger than r minus 1, is n r minus 1, x to the power of n minus r minus 1, y to the power of r minus 1. That is one way to look at it. Or term containing x to the power of j is n over n minus j. This is the combination of n choose n minus j. X to the power of j, y to the power of n minus j, and come up with the answer. So if you want to go with that route, the very first thing you notice, n is 8. Since we want the 7th term, okay, remember, r equals 0 would be the first term. So r equals 7. Okay, we are going with this, okay? X is being replaced by y, and y is being replaced by 3. So in this formula, n is 7, r is 7. In this formula, x is y is 3. So if we want to go with this one, n over r minus 1, x to the power of n minus r minus 1, y to the power of r minus 1. So replace the n with 8 and r with 7. So this becomes 8. This becomes 7 minus 1. So 8, 7 minus 1, y to the power of 8 minus r minus 1 is 7 minus 1. 3 to the power of r minus 1 is 7 minus 1. That's one way. and you finish it. But I want to actually show you an easier way. You don't have to go this. This is the formula that you find it in most text. I'm going to show you a way you don't have to memorize that at all. There is a much easier way. So we're going to write this for this case. Which means we're going to write y plus 3 to the power of 8 is this NR, which means 8 factorial over R factorial, 8 minus R factorial, x to the power of 8 minus R, y to the power of R. Now, x is replaced by y and y is replaced by 3. So let's write it. So we are going to write, again, you don't have to memorize, I'm going to write this one. Notice R starts with 0. So obviously it means this has the exponent 0. The very first term doesn't have this constant. Imagine it's x and y. So the first term, R is 0. The second term, R is 1. The third term, R is 2. Then the seventh term, R must be 6. R must be 6. Just go with this one. And now in this formula, all you have to do, replace the R with what you came up with. And the point I'm trying to make, the way they come up with that, you don't have to memorize this formula, just which becomes this formula, by the way. The seventh term, R is equal to 6. So with this one, replace the R with 6, everybody. So you get 8 factorial over 6 factorial, 8 minus 6, 2 factorial. Y to the power of 8 minus R, 8 minus 6 is 2. 3 to the power of R is 6. So 8, 6. Y to the power of 8 minus 6, 3 to the power of 6, and expand it. To simplify this again by hand, because 6 is the largest in the denominator, go with 8, 7, 6 factorial. By the way, 2 factorial is the same as 2. This way, everybody, and this is 3 to the power of 6, 729. You can cancel these two. And 2 factorial and 2 are the same. And so the answer is 20,412 y squared. I want to quickly recap this. You can memorize this formula or ignore that. You already know this formula. Either you write it in this format or in this format, it doesn't matter. Just remember, since R equal to 0, the first term R is 0. And then the second term must be R equals 1. What do you want? The seventh one? So that means R equals 6. That's all. And that takes care of the business. Very straightforward. Assume 8 people enter a swim competition. In how many ways could the gold, silver, and bronze prizes be awarded? Now, remember the combination. Order is not important. In the case of a permutation, it is, and it has a different formula. So a permutation of n elements taken R at a time is one of the arrangements of R elements from a set of n elements. If P and R or P and R in this, these are different formats of saying the same thing, denotes the number of permutations of n elements taken R at a time, with R being less than or equal to n, then permutation of nr is n factorial over n minus r factorial. Note, order within the group of R objects is important. In this case, is the order important? Yes. This, a permutation of 8 people taken 3 at a time, order within the group is important because the first one gets gold, the second one silver, and so forth. So order becomes important. So permutation of NR, permutation of 8, 3. So 8 factorial over 8 minus 3 factorial. And this is 5 factorial. Now, to do that, there are several different ways. I'm going to quickly show you all ways. One is to write this out, 8 all the way times 1, 5 all the way times 1. Or, like I said, because 8 is larger than 5, just stop at 5 and drop those. 8 times 7 times 6, which is 336. This is doing completely by hand. I mean, if you show work and then you want to use a calculator, is fine, but you have to show work. And the way it works with the TI calculator, first you have to enter the value of n, then press math, then select probability, select either NPR or NCR, or in this case P, okay, depending upon whether you want to go with a permutation or combination. And so math, we're going to go with NPR. Remember, we've chosen the N. And so 8 NPR3 gives you the same number. So you can always ultimately use a calculator for the final calculation. It's not a big deal at all. And now, again, reminding you of what's a combination. And so combination of n elements taken are at a time a subset of items selected without regard to order is called the combination. A combination of n elements taken r at a time with r less than or equal to n is denoted by CNR or NR or CNR, and is sometimes read n choose r. And here's the formula again, as it was mentioned. Note, order within the group is not important. So how many different committees of 3 people can be chosen from a group of 8 people? It's important to know it's a combination. A committee is an unordered set, the arrangement of people, therefore order is not important. We just want a committee having 3 people. Order is not important. If you're choosing the first one or the second one or the third one in any order, it doesn't matter. It's a combination. So because 5 is larger than 3, okay, and 8 is the largest one, you're going to go with this, and you're going to write the top as 8, 7, 6, and you stop at 5 factorial. This one, you don't touch it. This one, you write it out. This way, again, if you want to simplify it fairly fast, these two obviously cancel each other. 3 times 2 times 1 is 6. So 8 times 7 is the answer. Again, you may use a TI. So you go with PRB probability. NCR, you've already chosen the N, which is 8. You put it in, and it gives you 56 as the final answer.